Welcome back to the morning show. You know, you can bend a lot of things, and that includes light. And our favorite mad scientist, Matt Sellen, is here, the wise guy, to amaze and amuse. And you brought more toys.
Oh, yeah. Well, we have a lot of cool things today, and colorful things, too.
Good. Yeah, that's true.
Let me explain something that we did last week, because this has to do with polarization. And it turns out that all light, if you just take a single light wave, it has a property called polarization. It either wiggles, as it goes forward, it wiggles this way or that way or sideways or some way like that. It has an orientation to it. So imagine that this pen is the orientation that the light wave is wiggling as it travels towards you, let's say. You can have something called a polarizer, which is just a piece of material which has been constructed so that the light wave only goes through in one sense. Okay, so in other words, it's like a picket fence.
Okay.
So it's like this thing. If this is a picket fence, it's only going to let light waves through that are polarized this way. But if they're going this way, they don't get through.
Okay.
So this one, okay, the first, what I have back here is just a fluorescent light. It lets out light that has all kinds of polarizations. This first one only lets out light waves that are polarized this way.
Okay.
The second one is rotated so that it's only going to let out things that are polarized that way.
Okay.
So that means that in between here, everything is like this, but it stops here. Nothing can get through.
Okay.
So if you look at the screen, it's very dark. Very little light gets through. Really no light gets through at all. But if you take an ordinary piece of glass with some cellophane tape on it and you slide it in between
your basic tape, right?
That's right. Why don't you slide that in there and rotate it a little bit. And you see the thing changing colors?
Ooh, that's really cool.
Isn't that interesting? So what's going on here is that what must be happening is that something in between is taking the light that gets to the center here and is changing the polarization so it's like this. So somehow the cellophane tape is rotating the polarization of the light so it can get through the second one, because if there's nothing in here, it's dark.
Right.
Okay?
Okay.
And so cellophane has that interesting property. It's called optical activity, and it's because the molecules in this cellophane plastic are very long, stringy things, and when you make this tape, you kind of stretch out the molecules along the direction of the tape, and if you put this tape in there at kind of an angle, it tends to turn the polarization of the light as it goes through. It's the same idea actually as that calcite crystal we did last week, where for different polarizations the light goes at different speeds through the tape and it causes it to rotate. But that's the reason you get these pretty colors. And it does this differently for different colors. So red and blue and yellow and green get their polarization rotated by different amounts. And so depending on how you turn this thing, you get yellow or red or blue or green. Yes. And so depending on how many layers of tape are at any given one spot, you get different colors. Okay, so it is pretty fascinating that you can take a piece of really crappy plastic with really crappy cellophane tape and it still looks extremely pretty like that.
It does.
And you can do this at home too. In fact, you can just get rid of this and you could use your Polaroid sunglasses to get the same effect. You can just kind of hold this behind there. See that?
Oh, that's really neat.
Yeah. So this is not real high science to be able to see this kind of effect. Okay, and I have some other things here that we can put in. Here's somebody made a little tricky thing, but it's really just a swan and a fish. Okay, this is just now the interesting thing is, and you got ahead of me there, which is fine.
Sorry.
No, it's okay. Is that
I like science.
Some pieces of plastic, like for example this piece of plastic here, it doesn't have the molecules oriented in any specific way. So when I put it in there, it sort of glows a little, but you don't see colors.
Right.
But when I squish it, suppose I just squeeze this with my hand.
Ooh, it changes.
See the colors changing? And so what's really happening here is that when you take some materials and you stress them, you cause them to have forces internally, then it also causes them to be optically active and to be able to rotate polarization. So you can actually measure stress in materials by looking at materials through...
That's what stress looks like, folks.
That's right. That's right. So if you're grinding your teeth, you know.
And so our next segment, we're going to show what syrup does.
Yes, and we're going to show a few more stress examples, and we'll show how we can use sugary syrup to do the same thing. It's pretty neat.
We're going to get all stressed out in the next segment of The Wise Guy. We'll be right back.